So, we heard a lot about solar already, and today I will talk about wind and solar, and of course I will also include other stuff like the very short term, what you just mentioned, very short term forecasting for solar, which was not covered yet. So all solar parts which I'm approaching were made together with NIWE and in this GIZ project which was mentioned. So that's why my co-authors are Dr. Heinemann from Oldenburg University, he's a specialist for energy meteorology, Dr. Balaraman, SDG of NIWE, and Dr. Girida as the group leader. So a very short block of commercial. So what's my company? I'm the managing director and co-owner of Overspeed. We have 30 years of experience in renewable energy, starting with wind, today doing more and more solar. Our core actually is consulting for investors, banks, and project developers. That's where we're coming from. Today it's not the biggest part of Overspeed. We are doing R&D as background, so we are always trying to be at the leading edge of the current development and developing and offering high-class services. System development, like forecasting, is a very big point in our company, and our main areas are wind energy consulting, I mentioned already. Everything which is related to that, like assessments of potential and things like that. This is also true for solar, but for solar we are always working with partners. Then system and software development, I will show an example in a second, and what we are here today, wind and solar power predictions, which is actually the biggest part of our company today. The system which we are working is called Animos, so it's a platform and a collection of models for different cases for wind and solar, for very short term, for short term, and for long term predictions, which was developed quite a while ago. So behind the name Animos, which is our trademark, let's say, there are a number of things. It's leading edge research and development, which always is ongoing. So we have a lot of partners who are from universities and research centers who are developing new ideas, new models, and also in-house, of course, we develop new models. Then the prediction models and modules itself, the system we call Animos, and of course the commercial wind and solar prediction. Today, worldwide, we are predicting more than 130 gigawatts of wind and solar. So this was a classification which I like very much from IEA for different states, and the maturity or the impact, depends on from which side you look at it, from renewables, from variable renewable energy generation. And you see, if you go from top to the bottom, we have Ireland, Australia, and Denmark at the very top, which have the highest impact and the most issues, because they are island systems, more or less. We heard about also the Australian blackout from Thomas Ackermann, yesterday, which was fortunately completely homemade. So that's something which could be avoided in the future. And then going down in the red group here, Italy, UK, Greece, Germany, Spain. And then in the yellow group, there's India. And we learned already yesterday, first of all, of course, India is chasing up and joining the red group. And so we are very happy that as Animos, we are providing forecasts for all the three blue ones, so for the islands, so the Republic of Ireland and Northern Ireland, for Australia and for Denmark as reference solutions for the energy markets and for the grid operators. And of course, what we also learned yesterday, that India here is in this yellow group. That's not perfectly true if we take a look at single states. Yeah? If we take a look at states like Karnataka and Gujarat and Rajasthan, of course, you are quite close in already now joining the blue groups. Okay, what are we doing else? We are specialists for offshore wind farm development. We developed an offshore wind farm in the North Sea in Germany from scratch, from taking the claim up to the whole permission process, and finally selling the license to Vattenfall. And the farm was built 2 years ago. It was a high sea offshore wind farm, 70 kilometers from the coast, grid connection of 250 kilometers. And what is getting more and more interesting also in India, and of course also in many other systems worldwide, are storages. We are working mainly on long-term storages, seasonal storages based on hydrogen, like this one here, a salt dome underground, which is 5,000 meters high below the surface, and where you have caverns where you can store hydrogen as a real long-term storage. So that looks, that's how it looks from the side. So these caverns are around 1,500 meters deep, and then you can store compressed gas into it. It could be natural gas, but of course in the future it will be hydrogen from excess wind and solar energy, and other gases which are produced by Power-to-X technologies. We are also working on power-to-liquid, so producing synthetic liquid fuels from excess wind energy. Okay, in India we are active since 4 years now with advising different players, RMC advice, wind and solar power predictions, satellite-based, very short-term predictions. It was a question for the last talk, and I will come back to that in detail in a second. We made this training program with the Renewable team, from which you have heard these nice other two presentations, and we are training currently for GIZ also the RMC operator. So thanks are also due for all our Indian activities to GIZ and all the other partners which are involved there. Okay, so back to the topic, wind and solar predictions for India, and the question is always what is special in India, and it's actually many things. Like in all markets, yeah, of course, as a commercial forecasting provider, you have standard solutions for many situations, but actually you have to adapt them to the local situation. It doesn't make sense to use a standard installation or modeling chain we are using in Germany or the US to apply that in India. In many cases, for example, it's better to look for other markets. So, for example, from Australia, much more things could be used here compared to what we are using in Germany and Northern America. And of course, we heard already about some issues, and I will extend the list a little bit. So I will talk about high-low wind seasons and model tuning. That's definitely something which must be taken into account, which we don't know to that detail in other countries. We have very strong daily patterns in the wind and in the atmosphere. We are talking about curtailment, not so much, that will be more in the future, but unavailability of wind farms, of substations, and. So that's something which pollutes our data and makes it more difficult to make good predictions. Then I will talk about solar power, or I will mention solar power soiling, and I will talk about the very short term based on satellites. So high-low wind seasons and model tuning. You know the situation. Actually, it was the first activity we had in India in 2011, together with Armin in France and Terry here in India. Well, that's the time series of a wind farm at that time. Over the years, so that's 1 year, and of course you know that better than I do. There are seasons with there's a season with very high winds and a season with quite low winds. That's the current situation, of course. If we talk about model tuning, and we heard something about that already in the other two talks, of course, in general, this model tuning is adaptive, so you improve your model over time. This is an example below where we have improvement by adaptive tuning of one of our standard models over half a year. On the left side, you see the model error, so that's something you do today as a standard approach. And of course, when you're in a situation like India, where you have high and low wind speed periods, if you tune your model in this period, it won't help you very much. And of course, adaptive model training also has a forgetting function, because you don't want to have much influence from the data which is really old. But in this case, of course, you must, because if you have a forgetting function of, let's say, half a year, then you will lose all information which you have about the high wind period, and your model just will not work at the beginning of the next high wind period, so you definitely will fail there. So you must change your adaptive model trainings so they are feasible for the current situation. Okay, so that was the first point. Second point, thermal status of the atmosphere. Let me show you a time series. It's 1 day. Power, actually, the green line. It's a very strong daily pattern. Looks a little bit like solar. Unfortunately, it's not, but that's wind. It's a wind farm. And you can see it goes actually from 0 at, let's say, 5 o'clock in the morning, up to full power and down again in the evening. So it's a very, very high gradients and very high variability. Actually, this time scale is a little bit misleading because it's in UTC, so the red line would be noon. And this, of course, there's a reason for this variability, because if you take a look at the atmosphere on the left side, you have some winds at higher altitudes, and they are driving finally by forces due to turbulence, the wind in the lower atmosphere, and that depends a lot on the thermal stratification of the atmosphere. So how much convection is there, how much interaction between the different parts of the atmosphere is there. And of course in India this influence is very high because we have long periods with very high irradiation, so we have a lot of mixing, and this makes these daily patterns. And at the right we have a vertical wind speed profile. The greenish one is the regular one, and with high irradiation you get much higher wind speeds depending on the current status. So, and that's something which is not modeled very well by NWP models in general. So you have to add some physical modeling afterwards to take that into account and really pick it and get the right days where this happens and other days where it's not. And there's not a single event. This is the same wind farm, but now a whole week, and you can see it's really happening every day. 0 at nighttime, going up to almost maximum power during daytime, and then going down again. As I said, NWP models alone don't model that very good, so we must do some atmospheric modeling behind that. Okay, the power data that also was mentioned in the other two talks already. Without good data quality, you cannot do a good prediction. That's natural. And I think there should be as much effort as possible in making the database good, which you have. And of course, you also try to automate things. So, of course, in practice, you must live with what you get. And curtailment and unavailability are current issues, not only, of course, in India, but also in many other countries. So you have situations where you actually, in this case, you have curtailment by the grid operator. The same is happening if you have unavailability of parts of a wind farm or parts of the inverters of a solar farm. And of course, you try to detect that. Again, like Barun just mentioned, you try to assign flags to the data automatically where you say, yes, that's good data. Yes, no, that's something where I must take a closer look. Yes, I can use them for tuning. No, I must sort them out and don't use it directly for predictions, but of course in the very short term. So automatic detection of errors helps a lot, and we are investing a lot of time and money into getting these things, because you cannot sit there and sort it out manually. It's just not possible, but you must have good detection algorithms who find out where are issues in the data and how can I overcome them. Okay. It's the same which I said for wind, for seasons, of course, is true for solar. Of course, you have periods where you have very clear sky conditions. You see already, if you take a look at the peak power on each day, clear sky is not clear sky, in particular not in India. So you have clear sky days with no clouds where you don't see the blue of the sky. And you have very, very nice clear sky days where you get very high irradiation. So that's very different from day to day. So it's also something which must be taken into account in the tuning and in the classification processes of different days. So someone was already asking about classification, clear sky, not clear sky. And due to the high amount of humidity and aerosols, sometimes it's not so easy. So it's also the other way around. That's definitely something which has been developed further compared to Europe and Northern America for the Indian situation. And then, of course, you have the days with broken clouds. And again, you can have weeks of clear sky conditions if you don't take that into account in your tuning of the models and your tuning to clear sky. And then when you end up in a week with many clouds, then you're lost and the tuning of your models is not right. So again, that must be adapted. So soiling is an issue in India. So you have plants where you have very high impact from soiling, and there will be a talk tomorrow about a project which was performed with Oldenburg University, ASE and Nive. So I will not go into details, just mention it could be 10%, 50% if we're unlucky. So in most farms, solar farms, we have a cleaning routine which is followed, so it's important. And of course, rain has a high impact on that. If it's raining heavily, then the soil is coming down from the panels. And local measurements help a lot in the future because we are talking about grid codes and requirements in the beginning. Local measurements could help a lot. If you have two panels in a big solar farm, one is cleaned every day, one is not. This is additional information which can help you a lot to make better predictions. By the way, of course, it also helps in monitoring the power output of your farm. So as I said, that will be presented tomorrow in the forecasting session, the other forecasting session, I think. Actually, that's the first long-term soiling experiment in India, so which is running at Nive, was started 1.5 years ago, I would say. So it's a very, very important work and also important topic for future research. Okay, so now coming to the very short term, you already mentioned when we are talking about the next hours, of course, NWP for solar is not the way to go, at least not for single farms. Yeah, nobody expects that I can now predict the weather or the cloud coverage of the sky tomorrow at 10:30. Yeah, it's just not possible. You don't know if you have not clear sky conditions. Yeah? So you need other methods for that. So if we take a look at the different time intervals in the center here, going from 5 minutes to 10 days for different forecast horizons. There on the left, it's for the very short term. There are statistical models which work quite well for short-term prediction. And here we have the NWP and physical statistical modeling for longer, so 6 hours up to some days. And if we take a look at the data, that's where I want you to focus on. Then here, of course, for the first hour, we can do a lot with the online SCADA itself. If we have an idea about the trend in the SCADA data, as the SCADA data is high quality. And here in the NWP domain, which starts after 6 hours, we are doing not so badly. And obviously, there's a gap. And the gap in between, the idea is to fill that with satellite images, which we have in different places in the world. So that's an example from Australia. I like that as an example because part of their satellite images are in color. And so it looks quite nicely. And you see here on the right side this band of clouds, which is covering, unfortunately, the big cities, in particular Sydney, which in this case caused a lot of issues because it was predicted totally differently. So we are filling that gap with satellite images. 1 hour, 2, 3 hours, 4 hours works quite well for single installations, maybe 4 hours for states. And the idea is, it was mentioned already, you take consecutive satellite images. I will show an example in a second. Make motion vectors out of it, and on base of that, you make cloud prediction. So like always, the principle is very simple, and the problems and issues are lying in the details. So there are a lot of different things which could go wrong with satellite images and these prediction processes. So you need a little bit experience with that. Satellite images are provided by Weather Service worldwide, and of course India is a nation with a long experience and track record in space science, and sets a picture from the Indian weather satellite InSat 3D, which is operating since quite a while. So India is more or less in the center of the picture, not in the center of the picture, but the longitude is in the center of the picture of India, and these images are of very high quality and can be used quite nicely. So that's a related Indian satellite. And here I show a short sequence of that, where you can see quite nicely the movement of the clouds during the day. And if we zoom in a little bit, so we can see that band of clouds here south of Gujarat. And same pictures, just zoomed in. You can see quite nicely how the clouds are moving. And from that, as I said, from the consecutive images, you can make a prediction for the next half an hour to 2-3 hours for the very short term. That's an example from Australia, a rooftop actually where the greenish one is a NWP-based prediction, and it was totally wrong. The blue one is a production, and so there was much more energy from the rooftops than expected, which could happen. As I said, nobody expects you to really make a good estimation of the clouds tomorrow in a single area. For the whole, it's always different, but clouds bands could move a little bit, so 100 kilometers to the right or to the left, and you're already lost with your predictions. And in this case, the satellite-based predictions performed very well. So the satellite-based, so actually the NWP-based is a day ahead, and the red one, the satellite-based, is 3 hours ahead. So that gave us reproduced the situation quite nicely. So if we take a look to the very left, there's still a gap between the 5 minutes, 15 minutes, and the satellite images, and there are activities to implement sky imaging based predictions. There are activities at NIWE currently together with Waldl University and another demonstration project in one of the big solar farms in Andhra Pradesh, where sky cams will start to be used for, so actually you're looking up to the sky, taking an image of it, again take consecutive images so you have an idea where the clouds are moving, and then you try to make a prediction for the next minutes, what will be the coverage of the clouds, what will be the cloud coverage of the sky, and how will this influence your power production. So that's definitely much more research, and the other methods I explained. Of course, there's research also about the other methods, but that's fading into development, let's say, while in the sky imaging, there's still a long way to go. So it's the other way around. It's an excellent topic for research institutes. Okay, so concluding, India is a challenging environment, so it's not so simple just take the methods we learned for many years in Europe, US, to apply them here. We have strong seasonal effects, we have strong thermal influences, which provide us very strong daily patterns in wind. We have the data influenced by non-availability and in general SCADA issues, like everywhere on the world. It's not an Indian-specific topic. It's always, the issues are different, but all engineers know that when you start to measure something, then part of it will be crap. It's just like that. And you must learn how to deal with the local situation. Aerosols and humidity coming to solar play a big role, of course, and soiling has to be taken into account. As I mentioned, we are currently developing together very short-term forecasting with Indian satellites, so that's close to operational. So we expect operational later this year, beginning next year, and fine-tuning of models and processes improves the predictions significantly. So if you have any questions in the future, just drop me a mail. My mail address is here on the slides, and thank you very much.
Thanks, Professor Waldl. I think you have covered the overall gambit on the forecasting of both wind and solar. So the floor is open for any questions and clarifications. Yeah. No, I think he's got a mic. Okay, sorry. No, yeah, you can go ahead. Just give me a minute.
I am from Rajasthan, and we have got a phenomena of shifting sand dunes. So what happens is that that is actually not captured by the satellite. So when a part of a sand dune shifts from one place to another, then there are two-pronged effect. Number one is the panel gets soiled and the frequency of cleaning increases. And secondly, the irradiation goes down. I'm just wondering whether that is, during your fine-tuning, whether that has been incorporated or you intend to do that? because it is a very specific phenomena. I think it is not anywhere in India except Rajasthan.
Yeah, we should be honest. I think that's definitely a very specific thing. We have seen that in time series here when we go much below from the energy production, or power production, I should say, what we expect from a totally covered sky. So it goes down to 100 watt, 50 watts, and even below. So lower than German dark winter months, actually. And I think that's definitely a challenge, and it will remain like that for a while. Because as long we don't have good forecast for that phenomena, whatever the models for that are, I don't believe that we will cover that. What we can do and what we should do is taking a look closer into the possibility of have an early warning system for things like that, because it will approach through the countries step by step, and there could be a chance to detect that at least as an extreme event, but I don't think that in the near future we will be able to predict that.
Okay, yeah.
Yeah, thank you. Wonderful presentation. It's always good to listen to you. Jörg Gebler, GIZ, India. So I conclude what the snow is for Germany is the soiling for India. Yeah. I don't think you do anything on forecasting snow and the snow removal or sliding away from the panels. You do? Mm-hmm. So what is your, let's see, projection for soiling when it comes to distributed solar, not so much for the large scale?
Yeah, I think it's both. So for utility-sized solar, I think we need more measurements. Yeah, we need more requests towards the project developers and the operators to have a proper measurement of that. So I think we cannot avoid that with the very big installations which are planned and already installed in parts of the country. For distributed solar, it's definitely also current research. I think there are some activities going on. So we try to learn which amount of, mainly this NIVE project, we try to learn which amount of rain do you need really to bring down the soiling, and how much is it building up in different areas. But again, also that's also true for distributed solar in the future. I think it's crucial that India has a number of very good maintained reference stations on the rooftops, like we're doing in Australia and in Germany, where you can measure effects like that. So finally, you can take it into account. So without measurements, it will be a very rough estimation always. But it's hard to have good maintained stations if you don't earn money with a good maintenance. Yeah? So from experience, it's not easy, but it's definitely a challenge which must be tackled. Thank you.
Hello, my name is Pukhraj and I come from Suzlon R&D, Germany. And in your presentation, you mentioned about the SkyCam, so that you can monitor in real time the cloud movement. Yeah. So my question is, what application you are targeting by using the SkyCams in the power system control or applications? Anything?
Yeah. It's about giving an early warning for big gradients, for big big solar farms in the next 15 minutes, maybe up to an hour. But I think you have some slides about that. Yeah, in the final presentation of Dr. Balarama. Yeah.
Thank you.
Yeah.
Good morning, I am Prasad from Terry. In your presentation, it's an excellent presentation, of course. In your presentation, you also mentioned about the variations of wind, seasonal variations and things like that. And in some parts of the world, there is some research happening about the variation of wind due to global warming and sea getting heated and the pressure difference getting down. So what is your call on that? Is it, what is your call on that?
Yeah, thanks a lot for that question. Actually, to be honest, I don't know for India. It's a good idea to figure that out. I know for Central Europe, and they are the current estimate is that the wind climate and the solar climate is not changing too much. If that is true, I don't know. Yeah, so it's very hard. If I take a look, so now we're going from the day ahead to the 20 years ahead, yeah, finally. and I know a little bit about climate modeling. I don't know how accurate these ideas are. It's a global tendency, of course, but for single sites, or no, not single sites, but single regions, I'm not sure if we really can trust what the models are saying. For example, what we experience at the moment, finally drastic change in the jet stream, which caused a lot of issues in Europe and Northern America, that was not really predicted by the climate change models at the moment. Yeah, so I think it's good to make a research about that. So I will find that out definitely. So if you drop me a mail, I ask some people I know who are working in that field, but I'm quite skeptical about how good these forecasts can be.
Okay, thanks, Waldl.
Hi,
Yeah, this one more.
I'm from Suzlon, and you have discussed on short-term forecast for solar. Is there anything short-term forecast for the wind as well?
For the wind, it's easier, fortunately, because it's not a single cloud which influences the wind. Yeah, so you learn much more from the existing time series of the development of the power together with the NWP data. So you don't have this big gap which you find for solar. So that's a big advantage, that statistical models for the short term and very short term work quite well if you look at a state level. Yeah, for a single wind farm, of course, the variations can be very big, but on state level, we are doing already quite well with the existing models and measurement data we have.